Good morning, my YouTube viewers. It's Crystal here. Uh, this video is the first video in my course, the Intermediate Excel course. And so this is the follow-on course from the previous course that I made, which was Basic Excel course. So if you're watching this video, what I would suggest that you do is you go through and you take the Basic Excel course, because I think it only has like maybe 9 videos in it, and watch the Basic Excel course, and then after you've taken the Basic Excel course, then you can move on to the Intermediate Excel course. And the courses are free, so you don't have to invest anything in the course except your time. And so once you have completed the Basic Excel course, which is in my playlist, so all you have to do is look at my playlist and you'll find it, then you can move on to the Intermediate Excel course. And so in this course, you should already know how to create a file and open a file and edit a file and save a file. So we're not going to go into that. If you need to learn how to do that, then you need to watch the Basic Excel course videos, because we cover it in that course. So in this video is lesson number 1 for the Intermediate Excel course. And so we're just going to go right into Excel. So we're right into Excel, and basically we have a lot of information to cover in lesson 1. And since there's so much information to actually cover, then what I've done is I've prepared this lesson beforehand, and I will just go over the code in the lesson. So the first thing that we're going to talk about is absolute versus relative cell references. So Excel is set up for relative cell references. So if you put a formula in a cell, so we're going to say here like 5, 10, and then we're going to say, equals K2 plus L2. So that's 15. So it's set up for a relative cell reference, and you can tell that it's a relative cell reference because it doesn't have a $sign between the K and the 2 and a $sign between the L and the 2. So that's letting you know that it is a relative cell reference. But let's say you want to move the formula, because there's a formula in the cell. So we do Control C to copy it, and we're going to move it over to O, Control V to paste it. And then so basically what that says, so now rather than being in M2, now it is in O2. So that's M2 plus N2 is also 15. But what we're going to do here is we're going to clear M2. And then so when we've cleared M2, you get a values error. And so what the value error is telling you is there's not anything in M2 and M2. But let's just clear this. So equals 5, and then we're going to multiply it this time. Okay, so 5 times 10 is 50, and we've done that with a formula. So equals K2 times L2, which is a relative cell reference. So we're going to delete this. We're going to move it to O. So we're going to go Control X, and then we're going to move it to O with Control V, and it says equals K2 times L2. So even though we have actually moved the formula in the cell to O, it still keeps K2 times L2. And then let's move it again. So let's do Control X. Let's move it over to Q. Control Q. Control V. 50. And then so it's still saying K2 times L2. So if you move the formula, it's still relative. It's going to stay. It's going to keep that information. So that's just showing you relative cell references, that the formula in the cell is going to stay the same if you move it. And so that's good. That's really good, because like whenever you're working with Excel, you might want to insert rows, you might want to delete rows, you might want to insert columns, you might want to delete columns. And so what that does is that keeps you with a relative cell reference. But you also have something called an absolute cell reference. So you can tell an absolute cell reference because it's got a dollar sign. So you've got, we'll say F2. So if $F$2 means that it doesn't matter where you move the cell, the formula in the cell, it's still going to be dollar sign. It's still going to be F2. And so that is an absolute cell reference. And you have to actually go through and put $F, $2 in the cell in the formula. And so you have to code that in yourself. It's not done automatically. So relative cell references are done automatically, but absolute cell references are not done automatically. You have to code that in yourself. So I'm going to give you an example. So I've sort of given you an example of a relative cell reference. But so we've got here, you've got like P1. So you've got D3, and then you've got a value in D3. So let's just do this again, using a relative cell reference over in L2. So we're going to say equals 1 minus 0.75, so you're going to have a 0.25. And then so you want to copy that over, but what we're going to do is now we're going to say what, we're going to move that down to number 2, so we're going to just do this. So this is 1 on L2 is 1 minus E3. 1 on L3 is 1 minus E4. And L4 is 1 minus E5. So that's showing you that the relatives are, the cell references are relative, and you can copy and paste the formula into another cell, and because it's relative, that it will automatically change. But let's try this. So 1 minus $E, $3. So what that's telling you is that is making that E3 an absolute reference. And so if you copy the cell, it doesn't matter where you copy it, it's always going to be E3. So what we'll do is we'll take this and then we'll copy and paste it down to, and so you see here 1 minus $E, $3, 1 minus $E, $3. So that's your difference between absolute and relative cell references. So I've just given you a really tiny example, But in order to prepare for this course, I actually have given you another example of absolute references. And so what we're going to do is we're going to do a hypothesis test, but I can't do an entire hypothesis test in this lesson because this is intermediate Excel lesson. But if you want to learn how to do hypothesis tests or statistics mainly in my playlist, I do have some courses on statistics where you will learn hypothesis tests. And I have a course on statistics with Excel in my playlist if you want to look at it. So we're going to set the significance level to 0.05. And so the significance level is normally 0.05, but you can set it up for any value that you want. And it's mostly 0.05, but sometimes people do 0.1, or you can also do 0.01, but 0.05 is the normal significance level. So HO, that's your null hypothesis, means there's no significant difference. And H1, which is the alternate hypothesis, means that there is a significant difference. And so what you do is you check the means of two samples. And then and HO says that there's no significant difference between the means of two samples. You can also check the medians. And H1 means that there is a significant difference between the means of two samples. And then so basically you calculate whether there's a significant difference or not by using something called a p-value. And so if the p-value is greater than the significance level of 0.05, then it's going to be HO, which is no significant difference. But if the p-value is less than 0.05, then it's going to be H1 or HA, which is a significant difference. So we come over here and you see we've got 7 p-values ranging from 0.75 to 0.01. Okay, and then so we've got here, say, if E3 is less than or equal to F2, which is your significant level, you're going to say H0 or H1, but I've already made a mistake in that. So it should be greater than or equal to. So basically that's your formula. If E3 is greater than or equal to F2, which is absolute reference, then it is HO, which is a null hypothesis, and then otherwise it's H1. So we're going to go copy this all the way down. So you've got HO, HO, HO. And then, so what we can do is we can say here, just to test this out, mean 1 is 75, and mean 2 is 80. And then you can do a hypothesis test. And then so then you do the hypothesis test. And so basically it's just telling you this hypothesis test. And then so equals if 75 not equal 80, H1, H0. So you've got H1. So because 75 is not equal to 80, so it's going to give you the alternate hypothesis, which means there's a significant difference between mean 1 and mean 2. And so that's just the statistics part of it. So we're going to say, just so you can understand, so if the null value is greater than 0.05, no, sorry, if the p-value is greater than 0.05, then it's no significant difference. But if it's less than 0.05, then it is a significant difference. So we've got 7 p-values, and then so we've got a p-value of 0.75, which is a null hypothesis. And you see here, if E3 is greater than or equal to F2, then it's null hypothesis. Otherwise, it's alternate hypothesis. And so we go down if E4 is greater than or equal to $F $2, it's null hypothesis. Otherwise, it's alternate hypothesis. And you can see, you can go down the list, and you can see that because F2 is an absolute reference, so even if you have copied and pasted your formula, because F2 is an absolute reference, it's going to continue to be F2 the whole time. And so that's your difference between absolute and relative cell references. So I hope I've made myself clear on that if you want the formula to stay on one particular cell always, then you have to use an absolute cell reference. You have to put the $sign before the column and the $sign before the row, and that will give you an absolute cell reference. And so now what we're going to do is we're going to talk about mixed references. And so this is a mixed column reference. So it's an absolute column reference. So it doesn't matter. So with an absolute column reference, that means that you want the column to always be a certain column, but it doesn't matter what the row is. So you say $D3 in this instance. So that means it's always going to be on the D column, but it doesn't matter what the row is. And so take this, and then we're going to copy and paste it all the way down to number 7. Okay, so you can see $D4, $D5, $D6, $D7. And you can even copy and paste it, Control C. We're going to copy this, and we're going to take it over to F, Control V. And you can see that it's still $D3. And then we can use the autofill, and then so you can see even if you actually move the formula over to another cell, because it's an absolute column reference, it's always going to be in column D. So now we're going to do the absolute row reference. So the absolute row reference is similar to the absolute column reference, with the except that instead of having an absolute column, you're going to have an absolute row. So here you say $2. So you're going to be looking at column A, and column A can be any column, and $2 means that you're looking at row 2. And then now you've got, and you're going to copy this over. We're going to use the autofill. $A2, $A2. Well, that didn't work out very well. So we're going to do Control C, and then we're going to highlight the 2 cells that we want to paste it to, and then Control B. So that didn't work out well, because it said $2, and that said $2, and that said $2. So So let's move this over here. $2. Let's just move it over here to number P. And that says $2. So we have gone from $2, which is column A, to $2, which is column P. And then so basically the column has moved over because that's relative, but the row hasn't moved over. It's going to stay on $2. And you can copy that, Control C, and then we can paste it. So you can say M2, 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 M2. And so because the row is an absolute reference, even if you paste it onto other cells, the row is going to continue to be an absolute reference of 2. So that's just showing you that you can make an absolute reference for your column, you can make an absolute reference for your row, and you can make an absolute reference for your column and your row. And so here we've got $2, and then we pasted it to $2, and then we pasted it to $2. So that's giving you that's just showing you that you can have your 3 references. You can have your absolute reference for your cell, your absolute reference for your column, and your absolute reference for your row. So now what we're going to do is we're going to talk about the order of operations. So your order of operations is this little saying here called BIMDOS, and it could be PEMDAS as well, but BIMDOS stands for brackets, exponents, multiplication, division, addition, and subtraction. So that is the order of operations when you are carrying out mathematical computations. So you need to remember that. You can say either BIMDOS or PEMDAS because in the UK they say brackets, but in the US I think they say parentheses. So if you're in the UK, you can say BIMDOS, and then if you're in the US, you can say PEMDAS if you want. But this is the order of operations. Brackets is first order of operations. So if you see brackets, that's first. And then the second one is exponents. So if you see an exponent, then the exponent is going to take higher precedence than anything else other than brackets. And then if you see multiplication and division are next. And so basically what you're going to do is if you have a multiplication and division in your formula, then Excel is going to evaluate the operators from left to right. So whether it's multiplication or division, if it's on the left, that's the one that you take first. And then the next order of precedence is addition and subtraction. And it's the same way. If you have both an addition and a subtraction, then what you're going to do is you're going to take the one on the left. So multiplication and division have the same order of precedence, and addition and subtraction have the same order of precedence. If a formula contains operators with the same precedence, Excel evaluates the operators from left to right. So if you have a formula that has both multiplication and division in it, then you use the one from the left to the right as the first. And then if you have a formula that has addition and subtraction in it, then you go from left to right to make the computation. So we have some examples of orders of operation. So here's a very simple example of 5 plus 2 times 3. So 2 times 3 is 6, and 5 plus 6 is 11, because the multiplication has a higher order of precedence than addition. The next one we have is in brackets. So brackets has a higher order of precedence than addition, and it has a higher order of precedence than multiplication. So 5 plus 2 is 7, and then multiply that by 3 is 21. And so the next example we have is A33 plus 25. So A33 plus 25, so that's 11 plus 25, so that's going to be 36, divided by the sum of A33 to A34. So the sum of A33 to A34 is 32. So that's going to be 36 divided by 32, which is going to give you a value of 1.125. And so I've given you some examples of how you can write formulas in Excel. The first example being the most simple one, second example with brackets, and the third example with brackets and a division and a formula. And so we also have, after the order of precedence, what we have is the types of errors that you can have in Excel. And so what I've done is I've got the error types with a formula that has caused the error, and that says 10 plus 25. So that really shouldn't be an error. We'll just say ABC. So now you've got a value error, which is what I want. And so basically, first type of error you have is a value error. A value error indicates there is an issue with the formula or data being used. And then you can fix that by saying equals 10 plus value 25. So you've got 25 in parentheses, or 25 in quotation marks, and because 25 is in quotation marks, that's telling you that it's a text and it's not a number. Quotation marks lets you know it's text and not a number. So what you do is you type 10 plus value, brackets, quotation marks 25. So the value of quotation marks 25 is 25. So 10 plus 25 is 35. And so in theory, 10 plus ABC, it should be a value, but it's not coming up as a value. So it's defaulting it to the number. It's defaulting it to the number, but it's defaulting it to the number, but it shouldn't. What it's doing is it's saying, okay, it's calculating it as if it was a number, even though it's not a number. So it should be, in theory, it should be 25, but it's not. So what, and just to get the error, we're just going to say ABC. We're going to say ABC just to get the error, just so you can see that you have a value error, and then you would correct that value error by saying 10 plus value of 25, which is going to give you 35. So let's just try something. I just want to try something quickly. I'm just making it up as I go along, so it might not work, but let's try. So I made it up as I went along and it didn't work. So we'll just have to stick with it here, but it shouldn't do that. If the number is in parentheses, in quotation marks, then that means it's text. But for some reason, it's not working. And it did work when I did it yesterday. I spent all afternoon working on this. And it did work when I did it yesterday, but it's not working now. But I just wanted to show you how you get a value error, because you cannot add a number and a text. So that's going to give you a value error. And then we fix that error by making 10 plus value 25. So let's just see what it says here. So that gives you a value. So with the value, it will only work. With the value, it will only work with a number. And so the next error that we have is ref. So ref occurs when the formula refers to a cell or range that is invalid or no longer exists. So I've got an example of that. So index is B2 to E5 and 5, 5. So you come over here to B2 to E5. So B2, 2, 3, 4, 5. So it's only 4. And then, so it's actually 4. You're asking for an index of 4 by 4, but you're calling it a 5 and a 5. So that doesn't work. And then so now what we do is we change it. So index D3 to F9 and then 7 and 3. So that's going to give you H1. So you have D3 to F9. So you come over here to D3 to F9 here. And then you say 7. It goes all the way down to 7 and 3. So it gives you H1. And so basically what I'm showing you is how to fix that error. The next type of error you have is a division by 0 error, and it occurs when the denominator of any formula is 0 or empty. So we've got A33 is 11 divided by 0. It gives you a division by 0 error. And you fix that by saying A33 divided by 2, which is 5.5. So you take away the division, you take away the 0 and put a number in there, and then you'll get division by 0. The next type of error you have is a name. So the name error is a type of syntax error in the formula. And so basically this is a syntax error where we haven't typed sum correctly. Instead of it being sum, S-U-M, we've typed S-U-M-M to B33 to B35. And then we correct that by saying sum, S-U-M, which is the correct syntax, A33 to A35. And we have another error called NA. So NA indicates the value is not available to a function or formula. It's commonly seen with VLOOKUP when no match is found. So I've used the VLOOKUP, and I do actually use the VLOOKUP in my day job every week. So VLOOKUP brackets apple, comma, D3 to D9, comma, 2, comma, false. And so what that means is you're going to look for the word apple in cells D3 to D9, and you're going to look in the second column of that range of cells, and it should be. And you're going to look, false means that you're looking for the exact spelling. Well, there's not any D3 to F9. There's not any apple in D3 to F9. So we fix it by saying VLOOKUP brackets p-value 3 equals, because we got that, and then we look in the range D3 to D9, and then you look in column 2 of that, and then it's false means it's the exact spelling, and so you have 0.25 is what it prints out. And if you come over here, so we've got D3 to F9, and you're looking for p-value 3 equals, and then you're looking at column 2 of that, and it's 0.25, and that's what we've come up with, 0.25. And I do actually use VLOOKUP in my day job, so that's why I know about VLOOKUP. You also have something called if error. So what if error? That means if you have an error, then it's going to do something. So you're going to say you've got 25, and then you've got 0. So basically, so you've got if error, A45 divided by B45, and then you're going to say cannot divide, because it's going to go into an error, because A45 is 25 and B45 is 0. And so what's going to happen is that's going to give you a divide by 0 error. So rather than saying divide by 0, rather than giving you a divide by 0 error, it's going to say if error, A45 divided by B45, and then you're going to print cannot divide. But let's say here equals, so we get a divide by arrow there. So basic divide by 0 error there. So basically, instead of giving you the divide by 0 error, you can just say cannot divide. And then now what we're going to do is we're going to make a calculator, and to demonstrate all of the points that we've covered in lesson 1. So we're going to create a very simple calculator. What I did was I put a comment in operations, and somehow or other, I think it's because I put the comment in or something like that, but I've got these rows here, and I don't know what they are. I have no idea what they are. I don't know how to get rid of them either, so we just have to put up with it. But this is a very simple calculator that I've created, and you can recreate it just to show you all the points that we covered in lesson 1. So you've got number 1 is column A1. So then you're going to enter 100. Number 2 is column A2. And then you're just going to put a number in there, 0.05. And operation. And so I put a comment in there. So operations can be plus, minus, multiplication, division, and exponents. So that's what you can, that's the operation that you can perform in this really simple calculator that I've created. And this is your result. And so we've got a big formula in here that's a result. So it's a big if statement. $3 equals plus, it's going to be B1 plus B2. And then if $3 equals minus, it's going to be B1 minus B2. And it's if $3 equals star, it's going to be B1 times B2. If $3 equals, it's a caret sign, it's going to be B1 to the power of B2. And then we have if $3 equals divided by, it's going to be if error, B1 divided by B2, division error. So that's just going to say division error. And then otherwise, it's going to be an invalid op. So you got a really large if statement. So we're going to put here like 100 is your first number and 0.5 is your second number. And so the power of 0.5, so that's going to be the square root. So the square root of 100 is 10, but let's put 1 here. And so 100 to the power of 1 is 100. And let's put 2 here. 100 to the power of 2 is 10,000. So we can change this. So we can say, make it a time. So we can put a star in here instead of a caret. So 100 times 2 equals 200. And you can put a divided by. Put a divided by. So 100 divided by 2 equals 50. And then you can say plus 100 plus 2 is 102. And then minus 100 minus 2 is 98. And we'll just try another one. We'll just say and. And it says invalid op. So we're going to go back and put a little caret sign in there. That's exponent. So this is really simple calculator that we've made that just shows you that you can write a really simple program in Excel. So you're calculating two numbers and you can have addition, subtraction, multiplication, division, and exponentiation. And then you can type the result. And let's say here, make that a divided by, and then make that 0, and it says division error. So we've covered all of our bases here. We've covered all of our bases just to let you know that the error messages do actually work. You can get a div error if it's a divide by 0 error, and then if you put a number, a symbol in there that isn't in the if statement, then it will give you an invalid op. And so basically what we've done is we've covered a lot of the things that we covered in the lesson, and we've also made a calculator. So if you want to, you can try to recreate the calculator on your own, and you can see that you can always pause the video to get the function, get the formula in the cell if you want to pause it. And so that concludes this lesson. So the next lesson is going to be logical formulas and conditional workflows. And so I will prepare the lesson plan for that. And when I prepared the lesson plan for that, then I'll give you the lesson and you will know a little bit more about Intermediate Excel. So I hope that you got something meaningful out of this lesson, and I look forward to communicating with you in the next lesson.